right, so here is an example of how to do a problem that's elastic collision that has both conservation of energy and momentum. All right, so we have the before picture of a 10 kilogram ball moving at 2 meters per second, colliding with a 2 kilogram ball moving at negative 4 meters per second. Don't forget the negative, okay? All right, and then after we're not sure what's going to happen, the picture that I originally put shows it, but I might try to delete that part out, right? Because you really don't know what's going to happen afterwards, right? So we're just looking for the final velocity of each, but you can't necessarily pre-assume you know what's going to happen, okay? Kind of got to work it out and see, okay? All right, so what you're going to do is you're going to set up two conservation equations, okay? Initial equals final for momentum and initial equals final for energy, okay? Because it's elastic, so we know that the initial and final kinetic energies have to be the same. Okay, so I'm just going to set up M1 V1 initial, M2 V2 initial, M1 V1 final, M2 V2 final, okay? And then I'm also going to set up conservation of energy, 1/2 M1 V1 initial squared, 1/2 M2 V2 initial squared equals 1/2 M1 V1 final squared, okay, 2 V2 final squared. All right, so you'll see, I think, with these problems, it's not conceptually difficult at all. It's just kind of mathematically a little bit ridiculous. Okay, but there's ways to simplify it. Okay, all right, so let's go ahead and put in the numbers that we have. Okay, I'm going to just leave out the units because I'll never be able to fit it. Okay, so I'm going to have 10 kilograms times 2 meters per second. 2 kilograms negative 4 meters per second, okay, is going to equal 10 V1 plus 2 V2. Okay, I'm also going to drop the F subscript at this point because that's the only one there's going to be as final. Okay, so I'm going to go ahead and just dump that to make it a little cleaner. Okay, so 20 plus 8 is going to be 12, or sorry, negative 8. 10 V1 plus 2 V2. Okay, all right, and then I could just divide everything by 2. That's kind of convenient. Let's just do that. 5V1 plus V2. Okay, so that's going to just make it a little bit cleaner. All right, over here, the first clean thing I can do is just multiply everything through by 2 or cancel out all these halves. Okay, let's just get rid of that in the first place to make it a little easier. Okay, so then I'm going to have 10 times 2 squared plus 2 kilograms times negative 4 squared, okay, is going to equal 10 V1 squared plus 2 V2 squared, okay? All right, that's going to cancel out, so I'm going to have 40, right? Is that right? Plus 16 times 2 is 32. Oh, this is different than what I got last time. What did I do wrong? Oh, I know why, because I canceled out the 2s. I didn't do that last time, okay? Yes, this is the second time I've done this problem. All right, so 10 V1 squared plus 2 V2 squared, 72, equals 10 V1 squared plus 2 V2 squared. Okay, and look, let's just divide everything through by 2 again, okay, because that is just going to make it a little bit cleaner. Okay, all right, so now we have two equations with two unknowns, okay, so I can simultaneously solve these in whatever way you choose. Okay, usually the easiest thing to do is start with the momentum equation, right, and then solve for one and plug it in. Okay, this is nice because this V2 is really clean. Okay, so I'll get 6 minus V1, 5V1 squared. Okay, and then I'm just going to come put that over here. So I have 5 V1 squared plus 6 minus 5V1 quantity squared. Okay, all right, and now it's time for your fancy math skills. 36 minus 60 V1 plus 25 V1 squared. All right, and then I can just clean this up. 36 equals 30 V1 squared minus 60 V1 plus 36. And look, those cancel out. That's convenient. Okay, now what I did the first time that I messed up on, which I knew at the time I was messing it up, is you can't just cancel this, you have to factor it, right? So you know how like in math, right, they make you actually like factor it out, because if not, you might miss a solution, okay, if you don't actually factor it. So if I do 30 V1 is going to be V1 minus 2, right? Okay, and then my two solutions will be V1 either equals 0 or V1 equals 2 meters per second. So I'm going to have a choice. Okay, so whenever I get this quadratic, I'm going to have a choice, and then I'm going to have to think about which is the right choice. Okay, so at first glance, you might think that that 0 is the wrong choice. Okay, but in theory, it could, I guess, come to a rest, right? Okay, but look at this one. V1 equals 2. V1 started at 2. Okay, so that one for sure is wrong, because there's going to have to be some kind of a change in this collision. Okay, so V1 being 2 meters per second absolutely must be incorrect. Okay, so it's going to have to be that this guy is going to actually come to rest when it gets hit by this little ball. Okay, all right, so that seems kind of weird. So let's see what happens to V2 to see if we can make sense of that. Okay, so 5 times 0, right? So that would mean my V2 is going to be 6 meters per second. All right, positive 6. Okay, so this little tiny ball was coming into the left and then got shot off here to the right. Okay, so in effect, that could happen, right? Because this one had more momentum to start with. So the momentum is going to have to be in the positive direction, you know, afterwards. Okay, right. And then we can see, yeah, that's going to work out. Okay. All right. So those are your two answers. So let me see. So 2 plus, yeah. Okay. And then I can see it in here is there's a little shortcut. I'll link, I don't know if I want to show it to you or not. I'll link a video to it just because of it's a little bit of a shortcut, okay, how you derive that, right? But basically in an elastic collision, V1 initial plus V1 final equals V2 initial plus V2 final, okay? So we can see here this was 2 plus 0 meters per second, right? Equaled -4 plus 6 meters per second. So 2 meters per second equals 2 meters per second, okay? So that's kind of a shortcut way to do it. It's not super helpful, but in theory, that's kind of a little shortcut that you can derive from these equations, which I'll put a link to, which you should probably watch, okay? I don't recommend normally doing it this way, right? Because this is kind of like, to me, a sort of cheaty way. You need to understand how it comes about, okay? But you can see that it works.